Hey guys, so what we're going to be able to do today is we're going to talk about graphing logarithmic functions. So last week we took time and we talked about how to change between exponential form and logarithmic form. That's what we did on Monday. And then on Tuesday and Wednesday we talked about expanding and condensing logs. And then Thursday and Friday we talked about solving exponential and logarithmic equations. So today we're going to talk about graphing logs. Okay, now hopefully the sub gave you a paper, and so you're looking at problem number 1 now. Okay, and guys, graphing logs is super easy. Okay, so the first thing I need for you to know is that to a log, assuming the base is greater than 1, which for all of our examples today it will be, all right, this is the shape it should look like. Now remember that logs are inverses of an exponential, and exponential inverses of logs. Okay, if you remember, the exponential function had a horizontal asymptote. Okay, that was where you remember that dotted line we had, dash 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 dash. Okay, well, since this is the inverse of it, it should have a vertical dashed line. Okay, now let me ask you a question. Let's check some trivia here. What is the location of the exponential horizontal asymptote usually? Usually it's right here at y equals 0, right? Just right here at y equals 0. So where is the exponential's where is the logarithmic's vertical asymptote? Well, usually it's located right here at x equals 0. So in general, a logarithmic graph looks something like, and I already drew it out to the right there, I'm just redrawing it again. It looks something like this. Which, remember, I don't ever actually touch this vertical asymptote at x equals 0. Okay? So let's just dive right in. Let's just kind of get through doing this problem. Okay? So there's 2 things you need to remember. Well, I guess more like 3. Okay? Draw your horizontal vertical asymptote at the right location. Move your starting point to the right place. And then if it's a growth, make it look like a growth. If it's a decay, make it look like a decay. All right, so here's what I mean by that. Our starting point for exponential was at 1, 0, or 0, 1. It was right there. So then, since this is the inverse, where is its starting point going to be? That's right, at 1, 0. Now, for this problem, though, I have some transformations taking place. I have a transformation of right 1, and I have a transformation of down 5. Okay, so that means I want to go from this point right here, I want to go right 1 more, and then I want to go down 5, and that puts me right there. So then the next thing I need to draw is my vertical asymptote. Okay, your vertical asymptote, which we just talked about, is usually on the line where x equals 0. Well, which one of these is going to affect a vertical asymptote? That's right, going to the right one. So I draw my vertical asymptote to the right 1 time. Boom. Boom. Now I look at my base. My base is a 6. That's a growth. So I draw myself coming from the asymptote, cutting over like a growth. And there we go. That's it. Now it says identify the domain and range. Well, the domain, what's the most left x value? Well, it's this location of this asymptote, which was at x equals 1. And so it's from parenthesis 1 to infinity because I keep going to the right forever. And then range is from my lowest y value to highest y value. Well, I'm going down forever, and I'm going up forever. So from negative infinity to positive infinity. So boom, there's my domain and range. All right? All right, guys, that's the only one I'm going to do because I'm really hoping that you guys can really take it away from there. And just to remind you of which ones the sub is supposed to tell you that you have to do, you only need to do problems 1 through 8. All right, and they all follow that same basic idea. Make sure you're always going over to the right. You should never be going over to the left today. It is possible, but we don't actually get into it in our class. Okay? Alright guys, please send me a reminder or an email or get in contact with me if you have any questions. Please don't think that you can just not do this paper, okay? It is due on Wednesday. Thanks guys.